Good morning, everyone. I'm Dhriti from Sri Venkateswara College of Engineering, CSC AI Department, Bengaluru. Today, I will give a small presentation on Hough Transform. Let's move to introduction. Introduction. The Hough Transform is a technique which is used in digital image processing and computer vision to detect shapes or patterns in an image, particularly straight lines or curves. The Hough transform is a technique that locates shapes in images. In particular, it has been used to extract lines, circles, and ellipses. It was originally developed for detecting lines in binary images but has been extended to other shape detection tasks as well. The basic idea behind the Hough transform is to represent an image as parameterized mathematical equation. So this is about the introduction to Hough transform. Let's see the algorithm for the Hough transform. The first one is the edge detection. The first step is usually to apply an edge detection algorithm such as the canny edge detector to the point input image. This identifies the boundaries of the objects or the shapes in the image. Second is the parameter space. For each edge pixel, compute the set of possible parameters, that is m, c, that would satisfy the equation of a line passing through that pixel. The parameter space is a 2D accumulator array where each cell represents a possible line parameter. Next is outing. For each edge pixel, increment the corresponding cells in the parameter space. This is done by iterating through the parameters for a line passing through that pixel and increment the corresponding cells in the accumulator. Fourth is thresholding. After the voting process, the parameter space will have peaks or local maxima that correspond to the parameters of the lines. Threshold is applied to select the significant peaks and discard noise or false positives. The last one is line extraction. The significant peaks in the parameter space are converted back to the parameterized representation of lines. These lines can then be drawn on the original image or used for further analysis. So first we saw the introduction, next is the algorithm. So in algorithm there will be 5 steps included, so which we saw in last 2 slides. Let's move to the working. So a straight line is the simplest boundary we can recognize in an image. Multiple straight lines can form a much more complex boundary. We transform the image space into Hawk space. By doing this, we convert a line in image space to a point on Hawk space. Basically, we're trying to transform that image space into the Hawk space by converting a line in the image space to the point on a Hawk space. The equation of the line in the image space is in the form of y is equal to mx plus c, and the slope, where m is the slope and c is the y-intercept of the line. This line will transform into m comma c in the Hawk space, but in the representation m of the vertical lines. So let us use the polar coordinates instead. Next is the intuition for line detection. The intersection of multiple lines in image space represent corresponding multiple points in Hawk space. Similarly, the reverse, that is lines intersecting at the point m, c, can be transformed to a line y is equal to mx plus c in image space. So the line is represented by the length of the segment rho and the angle theta it makes with the x-axis. This line will be transformed to a point of the form that is rho comma theta in the Hough space. The Hough transform constructs a histogram array representing the parameter space, that is an M cross n matrix for m different values of the radius rho and n different values of angle theta. For each parameter combination rho and theta, we then find the number of non-zero pixels in the input image that would fall close to the corresponding line and increment the array at the position rho comma theta approximately, as we can look into the figures. If we have a line which is made up of many segments or the points close to the same line equation in this image space, that turns into many intersection lines in Hough space. We can see the difference here, that is the Hough space and the image space, which we saw in the earlier slide. Okay, so consider a line in the image space which is an edge detected and has small discontinuities. To find the continuous line in an image, we can transform this discontinuous line in image space to Hough space and look for intersection points in Hough space. This intersection point in Hough space will represent the continuous line in image space. We can see the Hough space as well as the image space here. And we can see here the inclusion for line detection and performing edge we can see, and also finally finding the lines using the Hough transform. Let's look into the advantages. Robustness to noise. The Hough transform is relatively robust to noise in the input image. It works by accumulating odds in the parameter space, which helps in reducing the influence of isolated noisy pixels. Detection of arbitrary shapes. Unlike other techniques that may be limited to detecting specific shapes or patterns, the Hough transform can be extended to detect a wide range of shapes such as lines, circles, ellipses, and more. Parameter estimation. The Hough transform provides a parameterized representation of the detected shapes, making it useful for estimating shape parameters such as shape, intercept, center coordinates, and radius. Scale and rotation invariance. The Hough transform can be modified to handle the scale and rotation invariance by incorporating appropriate parameters and accumulator structures. This allows it to detect shapes regardless or the orientation in the image. And some of the disadvantages. Computational complexity. The Hough transform can be computationally expensive, especially for large images or complex shapes. The voting process over the parameter space requires a significant amount of memory and processing time. Sensitivity to parameter settings. The performance of the Hough space is highly dependent on parameter settings such as thresholding and accumulator resolution. Choosing appropriate parameter values can be challenging and may require trial and error. Dis- discretization, discretization errors. The Hough transform operates on a discretized parameter spaces, which can introduce quantization errors. These errors can affect the accuracy of the detection, particularly when the parameter's resolution is low. So this is all about the Hough transform. Thank you.